So in this video, we are going to talk how we can implement distributed log using the Zookeeper. But before that, we should understand what is the distributed log, and this is one of the important system designs discussion used to be happen in all the offices, right? So first understand what is the distributed log. Before distributed log, let me go before the time when distributed system was not there. So you used to have the one computer, one desktop, and used to have the one database, right? And this is only one node, so anytime you can go update, delete anything. Your data consistent would not be happen. Your data integrity problem will not be happen because one system is there. But now time came for the distributed system, right? So distributed environment. So suppose if you have the huge tasks and you want to complete those tasks in certain time, right? And if you use the one system, it will take the way away time, right? Very huge time. So what you will do, you will add the many more worker node, right? So suppose this is the worker node 1, worker node 2, worker node 3, worker node 4, and the moment you are going to add, this is called the horizontal scaling, right? And this system is called the distributed system, right? So if multiple nodes are responsible to complete the one jobs, that is called the distributed system. But now problems arise here. So suppose as per your use case, these are your, suppose this is you called the sharing resource, means one resource is being shared by the multiple node. But at that time, only one node should be update the database. This is your requirement. So suppose you finish this task, whatever the tasks you share among the worker node. After completion of the job, one worker node should go and update the system. The job has been completed, right? Or one node is responsible to send the email to the management that this job batch has been completed, right? So now problem is that because each worker node are doing the same kind of the work, right? So at the end, when they want to update the database, all the worker node will go the database and they want to update. And this is called the race condition, right? Who one is going to update these things. So there are the many problems would become here. One problem is called the integrity, right? Suppose this worker node update. After that, this worker node also update with the some other data or the different kind of the time stamp, right? Second is the consistency, right? Suppose this database is a distributed database and different worker node are giving the different type of the data, so that consistency will be there. Third efficiency, it becomes the efficiency also, right? So suppose to update the one database with, suppose you have the one completion job, they take the 10 minutes time. So if all the worker node is doing to the same things, again it will take the huge time unnecessary, it was not required. Only one update from the one node was the sufficient. So how it be possible to do that, right? And so suppose then what is the things? So you should have maintained some lock, means the moment this system W1 is going to update something on your resource sharing kind of thing, first he should acquire the lock, first step, and then only we should go to the database, and third step, they should release the lock, right? This should be happen. If it is not happen, then it will impact the many more use case. So suppose what was the kind of the use case that will impacted with not having the distributed lock. So one is that your banking system. How? Suppose this is your bank, right? And one person account, suppose the person name is P, in his account we have the dollar 500, right? And here is the ATM where that person can withdraw the money, and here is the online service by which they can also transfer the money and withdraw the money from bank. transfer the money from bank, and also they can go to the bank counter and they can withdraw the money. If you think that distributed lock is not there, so he can also withdraw the 500. He can also transfer the 500, and he can also withdraw the 500. Right? So this system will not work. Right? Take the second example. So suppose for the reservation system, if you want to reserve some seat, right? If you want to reserve some movie seat or the buses seat, right? And if you have only two seats left and two people are trying to book with the two seats, so you can, if without having the distributed lock, this two seat could be allocated by the two different users that should not be supposed to be there, right? The third use case is the inventory management. In the e-commerce system, right? When you go and buy something on the e-commerce, right? It is showing the four items in stock, and these four item stock be visible by to the many users. So suppose multiple users want to purchase the four items and they be assigned to the four items, again system will be not the consistent, right? So this kind of the use case whether your system lock is must be mandatory to implement that. So how we can do that? So let me again draw the diagrams. What could be the possible, right? So suppose, so this is your resource, share resource. That could be database, that could be file system, that could be the notification system. And suppose these are the worker node, worker node 1, worker node 2, worker node 3, worker node 4. Okay. So as I said that some kind of use case that should be only done by the one person, or at a time only one person should execute that task. This is the more better good definition. At a time only one node should be execute that task. One process should be execute that task. So suppose W1 want to execute this task. So what we would do, so maintain some database. In database we have the one table that node ID and lock. So I will say W1 wants to lock. So I say the 2. So first this W1 will go insert the data in the database. First step. Second step, they will acquire the lock, do all the operation, second step. And third step, when they will come back, they will update to false or something or delete the data, right? So they release the lock. So when at the same time if W2 want to, suppose this was already acquired, it was true and he is doing the operation. This part is not done. The same time if W2 want to do update, they will say that W1 is already the true value. So if any true value is there, other nodes cannot be used that lock. So he has to wait. The moment this lock is released and this is the false, then they will go and they will update W2 is equal to true. And that time W3 and W1 want to do that, that is not possible, right? And this is the solution you think, right? But this is not the solution because this is the single point of failure. Single point of failure is a very important thing you have to handle in the case of the distributed environment, right? So how then what should be the solutions for that? Then solutions you should go for the distributed system. So this is the one solution that is not working. Second solution, go for the distributed database. Means you have one master database, you have one the slab database, and you have the slab database. This is complete distributed database is there. So these guys, when they want to the W1, they will go and first update into the master, and master will sync the data with the slab, right? Any point of time, if any database is down, other database is there to take care, right? So I can, this is the second solution that is also working nice. But here is the problem is that for the syncing, right, because it is syncing the data before sync, if the database is down, one problem. Second, they sync the one slab, they could not sync another slab, right? Then again the data inconsistency would be there. So again this third approach would not be work. Okay, let me try some other approach. The third approach. Third approach is that we will have the one resource manager, right? And whenever they want to acquire, so first they will talk with the resource manager, and then resource manager will talk the database, and the resource manager will have all the information what user is using the lock right now, and after that releasing that they can give that lock to other user, right? But here also the many problems is there. He has to maintain the distributed environment system. He has to sync the data. If any node is down, this guy's responsibility to make the node up, to make the proper thing. They should have the consensus algorithm to maintain, to sync all the data, right? So now I think this system, we can implement this system, but a lot of things you have to do that, right? Even that resource manager should be down. You have to make that resource system also the distributed system. So if you see a lot of things are there, so why you cannot use the Zookeeper? Because we have already ready-made solutions. Zookeeper itself is a distributed system, right? In my previous video, I have explained this is the distributed system itself, and the single point of the failure is kind of not possible in the Zookeeper. So why cannot use the Zookeeper for this purpose? So let me explain you how you use the Zookeeper to implement the distributed logs. So what you will do, so suppose you have the one resource, right? The log resource means there should be database, file system, notification system, that could be anything, right? And these are your the worker node who want to access this log resource, they want to that, but before that they should acquire the log. So here is your Zookeeper. Very easy solution is there. So what you have to do, so the moment this system want to lock these things, they will subscribe the Zookeeper. Subscribe means one node is already there, that is called the parent node. Give one name, you can give distributed rock something, this node, okay, and make this node is the persistent. What is the persistent node? When you say the node, this is the J node, okay. So in my previous video I have explained many times what is the J node and all those things. You can go and see that. I will give the link, and also this is the video where you can get all the ideas, right? Now whenever new worker node come, they will create one child node, very important thing, child node for the D lock, and they will give the name just lock hyphen, and this node would be the very important thing. This would be the ephemeral sequence node. I strongly recommend please go the previous video. I think the video number 3 where I have explained what is the ephemeral sequence and the persistent and all those things and where to use that. The moment you can make the sequence node, if you have given the name log, but they will append some values here, 1, 2, some number, right? And then this node appear the same time, and they also want the log. So first they have to create one, again the child node with the same name hyphen. So what the Zookeeper will do? they will again append the some continuous number. The same time these guys also want the log, so they have to again make the same name for the inferior node sequence, and this is the job. You created this node, but this is done by the zookeeper. You created this node, it is suffixed by the zookeeper, and here this is suffixed by the zookeeper, right? Because this is the sequential Z node, right? So now what happened? 3-4 persons are waiting for that. You put one logic here. Logic means in the each node, put the logic that take all the nodes from the D log. So get children from D log. This is your parent node. So you get 1, 2, 3. So you will get the 3. One is the log 0, 0, 0, 1. Second is the log 0, 0, 0, 2. Second is the log 0, 0, 0, 3. Right? Make it short and take the first one. After sorting, take the first one. Why I am doing? So you will get the node whose sequence number is the racer sequence. Racer sequence means he is on the top, right? Racer number is 1, but he is on the top. And the index first means child first. I will show in the code. Give the log to these guys. So then suppose this is the 0, 0, 0, 1. Give the log these guys. They will go acquire the log, do his operations. After the operations, what they will do? They will come back. After the operations, they will come back and they will delete the node. The moment they will delete the node, I have already explained the concept of the watches. Through these watches, again one callback method will call, and who is the waiting line, who is in waiting to acquire the log, again they will do the same things. They will make the sort, find out the latest node, and they will acquire the log. So we are taking the advantage of the inferior node to all these activities. Now think is that what was the biggest problem in the before approach, in the previous approach? So first approach was that they are doing the database insert, right, to make the true that I am going to take the log. And after acquiring the log, third point was that again they will database update to make the false. Suppose here only that node is got down, they will never come back and reach the log. That is will not happen in the case. The moment this node will delete automatically before deleting the node. So due to the inferior Z node, the moment this node will delete, this time zookeeper will delete this node, because by session which this node has been created, that session is not exist. So zookeeper will automatically delete this Z node, and the moment this node will delete, again the callback method will execute and they will give the chance who is waiting for this log. And this is how you can implement such a difficult distributed locking mechanism in easy way in just 5-6 lines of code with the help of the zookeeper. Let us go to the laptop and I will explain all those things through the running code, through the live code. Thank you.
So let me just show the code. So this is one Java class that I will demonstrate everything about the distributed log. So what you have to do, first you create one watchers, right, that we have already discussed, and very simple watcher. So and through the under the process method, just call the callback method and pass the node ID and the what is the parent node. So I have given the parent node is the D log, so that will be the parent node name, right, that we discuss. And this is the UUID, because we are running all the systems in the one laptop. So if you actually, you should have the IP address to distinguish the different node, but just for demo purpose we are making this UUID for the node identification. So this is the node ID, right? So we generate the node id, we will have the one parent node drock, and we have the watcher. So just I make the generic watcher, so if anything happen in any nodes, this would be callback executed. But for the better things, you can just check if the node changed, children changed event, then only it will execute. Just printing the node id, which system is that, because multiple node would be running, right? So all the nodes would have their own id. So we start the Zookeeper. If you see here, it is a local host 2181, and I have given the 1000 session timeout. Means each time Zookeeper come and check the heartbeat, right? Right. And this is watcher. This watcher just I made here, right? First and foremost, you have to create the parent node. If it is not there, then create it. So I have checked it. If this parent is not exist, null, then create the parent node without empty node, because I just need the empty. I no need to need any value for that. So it is created. And if you see, I have created the persistent, right, as we discussed on the whiteboard. This is the case where parent ID is not there or there, they will do that. But the main job is that for the any worker node, they have to create one inferior sequence. This is the important part of this complete discussion, right? And you just give one name. No need to give any multiple names. So what they will do, they will suffix some numbers after this node, right? That I will show you. And this is not, this is a simple Java code. So this is not a long running Java code. So I just make the thread shape. So the system should be continuous working while my demo session, right? This is my callback method. What I have done here, so anytime when the callback method is executed or hit, I will see how many children are there. So get children and given the parent node, my root node name, right? So then I can see how many children node, means how many worker node are active this time, right? And if any worker node is there, so greater than 0, what I am going to do, I am going to the sorting of all the nodes as I explain on the whiteboard, right? And get the first node, because their sequence would be the lowest sequence. Lowest sequence means the top priority, right? If you see the 1, 2, 3, 4, 1 is the lowest number, but it's on the top priority. Same thing, I will take the children, first children after the sorting, and then we see that if this node, the particular node, this node ID, if it is matching with the, if this node id is matching with the children, means this is the node which sequence number is the lowest sequence number, then I just simple the message, hey other guys, I acquired the log, and it will take the 10 minutes time or 15 minutes time to use the log, right? And then I will call the log function, means whatever the functions, whatever the resource I want to utilize, I can utilize during that time. And once I complete the job, I will come and do it the same thing, right? Whatever things I have created, I will do it the same thing. So the moment I will delete it, again they will, callback method will execute, and other waiting system will be acquire the log. I have just given that the else statement, that other guys accept the person, the node who got the log, he will say the message, okay, I could not acquire the log, I will be waiting here, right? And then this is my log function. Just for demo purpose, what I am doing, I am just printing the number from 1 to 10 with the interval of the 15 seconds. So 15 seconds, this is 15 seconds, right? So this is just, but in actual things, instead of just a printing, you could have the notification system, you could have a database update system, and inventory management, anything you can do that, right? Let me just run the code, but before run the code, you have to, to start the Zookeeper. So I'm going to start the Zookeeper. So Zookeeper is started, and also use connect through the client, Zookeeper client, right? CLI. Yes, I want to show you that how many these are the Z node we have right now. But with this code, we will create the new parent node, right? That the name I have given, this node name drock. Okay. So we are going to start the 4 worker node to see this demonstration. So first let me start from here, distributed locking demo, and this is the first one. So they must have get the acquire log, and you can see this is only one, right? And they got the acquire the log. Start another one here, right? And you can see this guy is in the waiting. So he say, so we wait, right? He also say log acquired by these guys, right? So now he got the chance. Now do one thing, Now you can see once it is completed the number, this guys got starting, right? Make all the four running together. So after this, these are the waiting, these are the waiting, right? See start, they have started one, and lock acquired by the four number, right? So if you see at the one time only one person is doing that, right? So this guys has been done. So if you want to again start, see at a one time only one person is doing that, right? So after this might be it will go to the here, right? Because it was the, it can be for this one, right? So after completing the 10, this worker node should acquire the log, or this one is taking that, right? As per the sequence they are working fine, right? So this is the complete code, and only the two important thing is the code base. This is the one ephemeral sequential. This is the important thing, and you have to do the sorting, and this is the main important two things are there in the code. Hope you will learn something new in this video. Don't forget to please subscribe the channel and share with your friends, right? So thank you very much.